Hello, I'm Giuseppe Luca, first year PhD student at the University of Palermo, and today I'm going to show you my work that is UV-induced modification in collagen molecular structure studied by means of fluorescence spectroscopy and microscopy. First of all, I prepared the sample, and the first one is obtaining irradiating the collagen with a UV lamp at 270 nanometers for 15 hours. And the second one is obtained the irradiating collagen with a solar simulator for only 5 hours. This difference in irradiation time is due to the different power of the irradiating sources. And both irradiating methods strongly affect the native fluorescence of collagen. In fact, in both cases, there was a dramatically decrease of both the tyrosine and ecrosilin peaks. And this parallels with a decrease of turbidity of the suspension that was measured as the absorbance at 450 nanometers. This decrease in turbidity is due to the increase of the solubility and the reduction of the object's dimension. To understand it, if it was any structural modification induced by irradiation, I did some CD spectra. And as we can see, there is a decrease of the aromatic patches in both the 3D sample. And so I decided to study more in depth what happened with this region. And so I decided to use ANS. ANS is a fluorescence probe that is sensitive to the environment. So I did some titration, and we see a decrease of the maximum fluorescence for the UV treated sample with respect to the untreated sample, and this denotes a reduction of ANS binding site affinity. Also, there is a redshift for both the samples that indicates that ANS experience a more polar environment with the increase of concentration of ANS. For the solar sample, the situation is a little bit different. In fact, for the 1 milligram milliliters collagen suspension, ANS is expelled from collagen just an hour later from the mixing of the two, and this means there is a total degradation of ANS binding site. While for the 2 milligram milliliter, we was been able to do a titration, and we obtain similar results to the one seen before for the UV treated sample. To highlight the heterogeneity in the sample, we use FLIM. So we studied the INS fluorescence lifetime, and we analyzing it by means of the phasor approach. We also use two different concentrations of INS. The lower one in the linear region of the titration, while the higher one on the plateau. And even for the untreated sample, there is a heterogeneity in the lifetime distribution of these two concentration. In fact, the lower concentration has longer lifetime that is associated with a more hydrophobic environment. Overall, the treated sample presents a shorter lifetime. In particular, the UV sample presents a shorter lifetime for both the lower concentration and the higher concentration. So the UV radiation affect both these binding sites, while the solar simulator is a little bit different because the lower concentration has the same lifetime of the untreated sample, while the longer concentration is characterized by a more heterogeneous lifetime distribution. So the solar radiation only affects the second binding site, the the one characterized by less affinity. So thank you, and I hope to see you in the poster session. Goodbye.